This is video number 2 for sections 7.3 and 11.2, the square root method. All right, we're ready now to introduce the method. Remember, we're solving quadratic equations, equations where the highest powered term has an x squared in it. And the square root method is the one that works only when there is one x showing in the equation. In fact, if you quickly scan through problems A, B, and C listed there, you'll notice that what they all have in common is the letter x is only written once. Well, I've given you the steps for the square root method in this box over here. Let's try them out on this first example. Step 1, every time you do this, you're looking for what is being squared. In this first example, I see the squared there. What's the base of that? Well, it's the x. The x is being squared. The first thing I need to do is isolate that. Isolate the x squared. That just requires a couple of simple algebra moves. I can add 21 to both sides. And then I can divide both sides by 6. Sort of getting rid of that junk like we always talk about. 21 over 6 reduces. I've got a 3 that's in common to both parts. So that reduces to 7/2. All right, once you get the base and power alone, now you're ready to move on to step 2. This is the big step, which is square rooting both sides. Remember that plus or minus we learned about in the last video. So I go here and I just square root my left side and I square root my right side, and at that moment it's incorrect without the plus or minus. All that's left now is to make sure that x is by itself, step 3, and then simplify the answer. Well, the x is by itself. The square root of x squared is just x. The other side, though, the right side, is not simplified. And this is why we went through all those rules of simplifying square roots. The first thing I notice is that I've got a fraction inside my radical. That's not permitted. Well, we learned that rule about splitting it up, square root of the top over the square root of the bottom. Let's see. I should check to see if I have any perfect square factors, but I don't. None of the perfect squares go into 7 or 2. The only last issue is the fact that I'm also not allowed to have square roots in the denominator here. So remember that trick. That's the one where I multiply top and bottom by the square root I'm trying to get rid of. That should do it. My final answers, x equals plus or minus. There are two answers. Square root of 7 times square root of 2 is square root of 14. When you multiply two square roots, you get a square root. And what goes inside is just the product of the pieces. And then on the bottom, square root of 2 times square root of 2 is square root of 4. Well, I already know square root of 4 is just 2. Here then are the final exact answers to the equation. Most of the time, this is what my math lab is going to want you to put in, the exact answers. And you have a couple of choices. There is, for most of the problems, a plus or minus symbol down in the keypad at the bottom of the screen. So you can certainly use that. Or the other option is simply to type in both answers with a comma in between. So square root of 14 over 2, comma, negative square root of 14 over 2. Either way is fine. There will be times where we want an approximate answer instead, and you would just go to the calculator. You would type this in just as it looks, the square root of 14 divided by 2. When I did it, I got around 1.87. Now, I don't need to type in the negative one. It's obvious that that would just be negative 1.87. And so here would be my two approximate solutions. On the TIs, the square root button is located in blue above the x squared button, if you haven't spotted it yet. And on some of the versions of the TIs, you have to make sure you exit the square root before you type in the divide by 2. And you can do that by using the right arrow. All right, let's go down to example B. And we'll try this process again. This is another quadratic equation. Once again, the letter x is only written once. and that means this is a candidate for the square root method. Step 1 is isolate the base and power. Isolate whatever is being squared. Now this time, the base is a little bit more complicated. Here's the squared. The base is this entire parentheses, 2x minus 3. I need to get 2x minus 3 squared by itself. Well, it's a couple of pieces of junk again. Subtracting the 6, and then dividing by 2, that outer 2 there. You might be tempted to start working with this 3 or this 2, but you can't right now because they're trapped inside this parentheses. Until you free them up from this squared, you won't be able to touch that stuff. We're done with step 1. We've isolated the base and the power. Step 2 is the big step where I come along and I square root this side and I square root this side. Whichever side has the number on it gets the plus or minus, like always, right? There's always two possibilities here. And let's clean that up. When I square root a perfect square, I'm just left with whatever was being squared. The square root of 2x minus 3 squared is just 2x minus 3 because 2x minus 3 times 2x minus 3 is 2x minus 3 squared. And on the other side, I have this plus or minus square root of 20. Now be careful here. We're not done. The x is not yet by itself. I have a couple of simple algebra steps. We're not saying that x is either positive root 20 or negative root 20. We're saying that 2x minus 3 is either positive root 20 or negative root 20. I'm going to have to work with that as I go through my algebra. I'm on the final step, which is isolate x. I will add this 3 to both sides. Now, how am I going to write that over on the right side? Well, 3 and square root of 20 are not like terms. I don't have any way to combine them together. So I'll simply have to write 3 plus or minus square root of 20. It's customary to write the plain old number first and then the square root second. It wouldn't be mathematically wrong if I had written plus or minus square root of 20 plus 3, but this is the convention. Finally, divide both sides by 2. My x is now by itself. I'm almost done with this problem. The only reason I'm not is that square root of 20 can be simplified. Maybe I'll go off to the side and do some scratch work. There is a perfect square that goes into 20, namely 4. So I can split this up. Square root of 4 times square root of 5. The square root of 4 is 2. So the simplified version of square root of 20 is 2 root 5. So back to my final answer here. I have x equals 3 plus or minus 2 square root of 5 all over 2. That fraction bar covers everybody. This is the final answer. The only way that occasionally you can keep going is if this number, and this number all shared a common factor. Then I could reduce, I could divide out, but that is not the case here. Here are the final exact answers. One of them is 3 plus 2 times the square root of 5, all divided by 2. The other is 3 minus 2 times the square root of 5, all divided by 2. These would be the exact answers. If I wanted approximate answers, I could go to the calculator. Now, it would take me 2 different moves to get these 2 answers. This time I would have to work it out using the plus, and then separately I'd have to work it out using the minus. Let me show you some options here with the graphing calculator. One way to get the approximate answer would be to type it in pieces. So you could type 3 plus 2 square root 5, hit enter, and then divide by 2 and hit enter again. And so there's our first approximation, 3.74. It's not too difficult, though, just to type it in all in one step. You just would have to put a parentheses around that entire top so that the calculator understands that you want to divide all of that stuff by 2. I need to arrow out of that square root and then divide by 2. So there's 3 plus 2 square root of 5 divided by 2. And then the calculator has this nice feature called the entry feature. It's right here in blue above the enter button. What it does, if you choose it, is it retypes for you the last thing you had typed in. And this is great for these quadratic equation problems because I can just arrow over here and change that plus to a minus. And now it's 3 minus 2 times the square root of 5 divided by 2, which gives me my other decimal approximation. And so my two approximate solutions would be that 3.74 and the negative 0.74. Well, finally, let's look at problem C. Once again, quadratic equation, 1x showing, perfect candidate for the square root method. This time my base is 3x minus 2, my power is 2. I'm trying to get that part by itself. I can do that with one simple algebra step, subtracting 4 from both sides. And then I'm ready for step 2, the square root step. Square root the left, square root the right, plus or minus at that moment. It's critical that the plus or minus happen at that moment, or you will probably make mistakes later on in the problem. When I square root a perfect square, I'm left with just what was being squared, the 3x minus 2. On the right, I notice this is going to clean up pretty nice. Now I'll just for the moment leave it as square root of 9, but the square root of 9 does have a nice answer. We'll come back to that. Let's finish off the algebra. I'm on step 3 now. Isolate the x. I'm going to have to add 2 to both sides. Remember, it's customary to put the 2 in the front and then the plus or minus part. And then divide both sides by 3. That takes care of the x being by itself. The final thing would just be to make sure my answer is simplified. As we already pointed out, the square root of 9 has a very nice answer, and I'm always expected to give those nice answers. It is just 3. Well, the thing is, since that part cleaned up so nicely, I can take this further. 2 plus 3 has a nice answer. One of these answers is 2 plus 3, all divided by 3. The other answer is 2 take away 3, all divided by 3. Well, I can write those down. 2 plus 3 is 5, divided by 3 would be 5/3. 2 minus 3 is negative 1, divided by 3 would be negative 1/3. You're always expected to simplify these things as far as you possibly can. This time the exact answers are very, very simple. Now obviously I could give decimal answers as well. That would be very easy, but these are the exact answers to the equation. I can tell you that when you do get nice answers like this, it is a tip-off that the factoring method would have worked on this equation, on this original equation. That's not to say that it would have been easy. It would have been a lot of work. I would have had to FOIL out this piece. I would have had to get a 0 on one side. I would have had to refactor. The factoring method would have worked, but I would say the square root method probably is the easiest method to use in this situation. For the rest of the chapter, when you see a quadratic equation with 1x showing, you want your brain to think square root method.